For example number 7, we're going to evaluate the integral of the function dx over x minus 1, going from a lower limit of 0 to an upper limit of 3. Now we're going to observe that the line x equals 1, which is in a denominator, is considered a vertical asymptote of the integrand. Since it occurs in the middle of the interval between 0 and 3, then we must use part C of definition 3. So there's your part C of definition 3, with C is equal to 1. Now, rewriting our integral in terms of this definition, knowing that C is equal to 1, we then take and expand this in two different integrals. The first one is going from 0 to 1 of the function plus 1 to 3 of that function. Now what we're going to do is rewrite this in terms of our previous definitions. So we take the limit as t approaches 1 from the left, going from 0 to t, dx over x minus 1, which becomes the limit as t approaches 1 from the left of the natural log of the absolute value of x minus 1 going from 0 to t. Applying the upper and lower limits, we get the limit as t approaches 1 from the left of the natural log of the absolute value of t minus 1 minus the natural log of negative 1. Therefore, we get the limit as t approaches 1 from the left, the natural log of 1 minus t, which is equal to negative infinity. Now, because 1 minus t approaches 0 from the right as t approaches 1 from the left, thus, this integral is divergent. And what that tells us is it implies that the other integral is divergent. So we do not need to evaluate this integral. Now, we should take a look at the warning though. If we had not noticed that the asymptote x is equal to 1 was in example 7 and had instead confused the integral with an ordinary integral, then we might have made the following erroneous calculation. We would have done the upper and lower limits and got the natural log of 2 minus natural log of 1, which would equal the natural log of 2. Now this is wrong because the integral is improper and it must be calculated in terms of limits. So from now on, whenever you see this symbol, you must decide by looking at the function on the interval whether it is an ordinary definite integral or an improper integral.